Hi, welcome back. We are working in Chapter 5 of our textbook this week on pictorials and sketching. So we're going to do a little hand drawing this week with pencil and paper. You'll want a couple of different types of graph paper, and we will talk about that as I go through this lecture, and I'll give you some online resources to be able to get that for free. So let's go ahead and I'll give you my screen and we'll go through this PowerPoint presentation. Okay, so in this chapter, what we want to do is understand why we want to be able to sketch by hand. And the short answer is sometimes we need to, it's just quicker to just create a freehand sketch than it is to do an AutoCAD drawing. And we use these skills in order to be able to communicate to people when we don't have a computer handy or AutoCAD booted up. And what we want to do, the way that we do these freehand drawings, we can create them. We can also use these freehand drawings to go from our orthographic projections to a three-dimensional image. And we use those orthographic projections to make those three-dimensional images using a couple of different projection methods. And we'll talk a little bit about axonometric, oblique, and perspective methods. And then you will practice drawing some of these. So I'm not going to read this to you. This is in your text as usual. But the reason freehand sketches throw in a couple of ways. In the engineering design process, we always start with an ideation or a conceptual design stage. This is kind of like the brainstorming stage where we just have kind of an idea what we want to do, but it's just basic concepts. Sketches are really important in this phase. In the design development stage, we've decided on an approach and we're now starting to develop the details around that. And during this stage, we typically use prototypes, and we've moved into computer fairly detailed drawings. So sketches really show up in the first stage, but in this first stage is when we're developing our idea, and so it's important at this point to be able to communicate clearly, even though we don't have all the information we want in order to create a CAD sketch. So we use freehand sketches to quickly take the designer's ideas and help look at different possibilities. This also lets us communicate those ideas with others, again, quickly and clearly. Clear communication is really the whole goal. So it is important to be able to sketch these with at least enough skill that the object can be recognized. Okay, so pictorials are really three-dimensional representations of this object that we know we can represent using our two-dimensional orthographic projections. But people who aren't used to working with the orthographic projections will have a hard time mentally rebuilding the object based on those images. So the other reason that we want to do this in this class is so that you can practice, because you're just learning about orthographic projections most likely. And being able to take those projections and turn them back into a three-dimensional image will help you solidify your skill in interpreting those orthographic projections and help you be able to create those orthographic projections based on an object. So one way in which we do this is with a technique called axonometric projection. What that really means is to measure along the axes. There are different types of axonometric projections. The most common is isometric. And you can actually get graph paper, grid paper, called isometric graph paper. And what it is it's graph paper that has got little triangles drawn on it. And I will post a link on the course website to a website that will allow you to print out your own 8.5 by 11 isometric graph paper. Isometric is probably by far and away the most common axonometric projection method used in industry. The next type of projection that we can do is called an oblique projection. And what we do is we take our object and we start with the front view, and then we just project back and up along some angle. And that allows us then to create the oblique projection of our object. Now you want to use your other two views in order to add in any detail that aren't shown on your front view. Perspective projections are also very handy and quite can create quite a realistic representation. And what these are based on is they're based on the fact that as we look farther and farther out into space, objects get smaller and smaller. So we identify what's called a vanishing point. And a one-point perspective has a single vanishing point. And we can start with our front view, draw some construction lines through that vanishing point, and then just project our front view back along those construction lines. Typically, in industry, if we're using a one-point perspective, the vanishing point will be above and to the right of our front view. We can also use a two-point perspective. So the way to think of a one-point perspective, that's like those images of the long, narrow hallway. The long, narrow hallway's got a one vanishing point. If we think about looking at the corner of a building and we're looking down two directions, then we'll have two vanishing points. And that's what a two-point perspective is. These are also quite handy. And you use both the front view and the side view to create these. Put the front view on this set of construction lines, the side view on the other set of construction lines, and then you project them back and fill in any details on the top view. So this is really like recreating your glass box. And then a three-point perspective is pretty much the same thing, except it's more like an aerial view where we're hovering up in the air. And so we've got vanishing points both behind or above and to the right, above and to the left, and then straight down. This is a true three-dimensional view. It can be kind of confusing to create. Typically, either a one-point or two-point perspective are sufficient. Okay, so let's talk about isometric sketching. Now, there are two different ways. I talked a minute ago about isometric grid paper that had little triangles drawn on it. This grid paper, this is isometric grid paper over here. If you look, the dots, you can make triangles out of them. They're on an angle. So these are our orthographic projections. We've got a front and a top. And what we've done is we've taken this front view and we've transferred this line that is 1, 2, 3, 4, 5, 6, 7, 8 dots long, and we've put it on the axis that runs diagonally down and to the right on our isometric sketch. And then we've put in the vertical lines and the horizontal lines, and then we've just connected this diagonal line. Diagonal lines and circles can get a little tricky when we're doing isometric projection, so always start with the vertical and the horizontal. Okay, so this slide is our front view drawn on isometric grid paper. We then use our top view to figure out how deep our object is. And so this dimension is transferred to this dimension, the isometric view, and along this line, and that's where this comes from, and this line, and then we connect all of them, and then we sketch in our circle. Now if you look closely, you'll notice this circle is not actually a circle, it's more of an ellipse. And what we do is we take this dimension, these three dots, and 1, 2, 3, and then the opposite, 3 dots, 1, 2, 3, and then we just sketch in the shape that connects them. Circles will become ellipses when you're doing isometric sketches. But in just those few steps, we have taken our orthographic projections and recreated our three-dimensional object. Okay. One of your assignments this week will be to do some of these, and you'll find that the details of those assignments on eCompanion. Okay, this is an example of how we use oblique sketches. So we don't have grids here, but what we've done is we've taken our front view, and you could do this in the same scale as your orthographic projection. And we've started with our front view. And then we've identified an angle, and we've just taken this corner and we've just drawn a reference line straight back on roughly a 30-degree angle. Now the next step is to project this horizontal line backwards on that same angle. And then we project, so we just take this front view and we really project it up and back along this angle. And then we sketch in the little U right here from the top view. So this isn't isometric drawing, although it's very closely related to isometric. Isometric really means that all three of our axes are identical in length. With oblique, we really just take the front view and we project it behind, and then we connect all the corners. Okay. And oblique projections are related to, but not identical to, one-point perspective. So this is that same shape drawn in a one-point perspective. And what we've done is we've identified our vanishing point back here in the upper right-hand corner of our page. And we just draw in some construction lines through key points in our sketch. From the front view, we project back along these vanishing points. And you can see 1, 2, so that's about 1, 2, 3, not quite 4. 1, 2, 3 dots. And we have 1, 2, 3, 4, 5, 6, 7. So we've got about a 1 to 2 scale. So what we've done is we've taken this 7-unit disc thickness and shortened it a little bit to be only about 3 units. So typically it's a 1 to 2 in depth when you do vanishing point perspective, and that's one of the differences between these different techniques and isometrics. Isometric sketches can be pretty precise and pretty measurable. These others aren't so measurable always, but this gives you a very nice visual representation of our part. So we utilize construction lines to project our shape back. Okay. Two-point perspective is very similar, except we construct 2 vanishing points. And what we've done here, so this box here, this one, this side shows the front edge. That's this shape here. And that's why we have the front projected on this side of our cube. Now, we get this side view by visualizing what we've got going on here. We've got a drop, and then an in, and then another drop. So that's where this little ledge comes in. And then on the top view, that tells us we've got a little ziggy here. And so we put this little ziggy on this top space right here. So we project our hidden lines up. That's what this is. And then we can create the rest of our shape. I'm going to leave these with you for practice, or so that you can figure this out. I encourage you to take this orthographic projection and a blank piece of grid paper and look at your vanishing points, or create your vanishing points, and then recreate this shape so that you can practice knowing what the outcomes are. So I encourage you to back this lecture up a little bit, pause it, and go through this exercise. These are also in your textbook, but you can do it here too. And so now what I want to do is I'm going to actually stop this slideshow, this PowerPoint, and I'm going to show you where to get some printable graph paper online. And I will also put these links out on eCompanion for you. So what I'm going to do is I'm just going to Google graph paper maker, graph paper PDF, graph paper printable. Any of those work. I usually go with graph paper maker. And there are a couple of options out here. This one's a decent one, this print-free graph paper. I think that's the one I like, actually. It is. Because here's what we can do. We're going to work on an 8.5 by 11 because that's what most of us print to easily. Let's choose our type, and I'm going to choose just isometric. And then we'll measure in inches, and let's do 1/4 inch. And then we can just click print. And this is isometric graph paper. It's the gridded kind and not the dotted kind, but this would work for isometric projection. If you wanted just Cartesian, rectangular, you can just go with Cartesian. You can do 1/4 inch, you can do 1 to 10. This is just the spacing between your grids. There are other options out there. So this one has got, pretty basic stuff. You can do engineering paper. That's not my favorite. I like it as smaller. So typically I do 1/4 inch or 1 to 5. When I do engineering graph paper, I typically do 1 to 5. So there's your standard engineering graph paper. It's just not green like we're used to seeing. We aren't going to work with polar. Isometric's handy. The rest of these aren't anything we're going to work with. The other one I like, is it this one? No. This one works. So this was when I did my Google search. This was the top one. And this one is what that was, the Incompetech. And if we look at the squares, what this does is it gives us options for a lot of different square options. My computer's locked up, but you get the idea. These are all PDFs. Here's dots if you wanted dots. It's just like normal rectangles, except it's got dots instead of lines. And if you're doing projections, sometimes dots are handier. And this one gives you a lot of control. You can control the size of your dots. You can really specify how fine your grid is. And you can even give it a color. And then when you're all satisfied, you can just, it just gives you a PDF that you could actually save to your computer and print as many times as you wanted to. These are all free. They don't require sign-ins. They don't require accounts. So for this chapter, there's no need to go buy a pad of graph paper. You can just download and print what you need. If you want to do isometric off of here, that's what you'll find that under triangle and hexagonal. Come on. Although usually when I use isometric, I just use the gridded one that I showed you a minute ago. Right here is your isometric triangle PDF generator. And you can get IsoDots is the dotted version of isometric graph paper. That's what IsoDots is. Okay. So that is all that you need to know from me in order to do this chapter. It's really a matter of practicing and building your skill, both at visualization and just drawing. And the best way to develop that skill is to practice it. So your assignments for this week, you will need to submit them either by scanning them and emailing them to me, or you can snap a picture with your phone. Just make sure that it's legible, and you can email that image to me as well. If you're in Pendleton, you can always drop them off by my office in person. All right, that's it for Chapter 5. Check eCompanion for the actual assignments. Check the course website, and I will see you again soon.